When the Andromeda Nebula transformed into the Andromeda Galaxy overnight, it was a holy moment. For a really long time, how we might interpret the Andromeda world was restricted to ground-based perceptions. Our knowledge, on the other hand, has exploded in the wake of technological advancements and the establishment of the James Webb Space Telescope. Now that the James Webb Space Telescope has detected alarming signals emanating from the Andromeda Galaxy, things are about to change. Astronomers have been inspired and intrigued by these signals, which have shocked the scientific community. But exactly what do these signs imply? Most importantly, why are astronomers so concerned about them? Go along with us as, only 2 minutes prior, the James Webb Telescope shut down in the wake of getting disturbing signs from the Andromeda cosmic system. Before we could see a long ways past our eyes into the universe, space experts trusted the smooth method for being the entire universe. The lack of tools for observing galaxies and individual stars was primarily to blame for this ignorance. However, when we discovered the Andromeda Galaxy, everything changed. It provided us with our first clue that the universe extends far beyond the Milky Way. All of this started in the 17th century, when Galileo Galilei's groundbreaking work with telescopes revealed the true nature of the Milky Way. He saw that the Milky Way had a lot of stars, which shook up the idea that it was only important to one thing. When Edwin Hubble used the Hooker telescope to find distant objects beyond the Milky Way, everything changed in the 1920s. Edwin noticed that these celestial objects were galaxies that were distinct from the Milky Way as they moved through space. One of the systems was the Andromeda Universe, or M31. The Andromeda Galaxy was first observed by Persian astronomer Abd al-Rahman al-Sufi in the 10th century, and this was the first time we saw it through a telescope. Astronomers were able to observe and comprehend the true nature and essence of Andromeda as a result of advancements in technology during the 20th century. Similar to our own Milky Way, Andromeda is a vast galaxy in a nebulous cloud. The distance between our cosmic neighbor and the Milky Way is about 2.5 million light-years. The way we study Andromeda has changed a lot since it was found. We have moved from ground-based perceptions through telescopes to space observatories like the Hubble and the James Webb Space Telescope. We've learned more about the Andromeda Galaxy's secrets with each technological advancement. Andromeda is now a standard for studying the formation and growth of galaxies because we now have more information about its composition and structure. As a result, we now know more about how the universe works in general. Given that Andromeda and the Milky Way are bound to collide in about 4 billion years, scientists believe that we must investigate their relationship in order to gain a better understanding of our universe and the Milky Way. The James Webb Telescope recently received an alarming signal from Andromeda, despite the fact that research and investigations have advanced. Scientists all over the world are baffled by this alarming signal, which has them wondering where it came from and what it might mean. The advanced sensors of the James Webb Telescope have found unusual activity right inside the core of Andromeda. Scientists from all over the world are intrigued by the signal that shows results that are significantly different from previous observations. The signal indicates significant processes taking place within the galaxy, which may be connected to its supermassive black hole or to events that have not been observed before. One of the most recent discoveries, in particular, suggests that Andromeda's mass may be significantly greater than that of the Milky Way, reshaping our perception of the sizes of the two galaxies. The formation of new stars, as well as the chemical compositions of those stars, have been revealed thanks to the James Webb Telescope's comprehensive images and spectra of Andromeda. This new information is significant for figuring out cosmic development and expected conditions forever. In addition, the telescope's data suggests that Andromeda's active galactic nucleus is experiencing increased activity, which will eventually have an effect on the planet's environment and shape its future structure. In addition, by investigating the gravitational effects of stars in Andromeda, researchers learn about the galaxy's mysterious dark matter distribution and hope to improve our comprehension of how it affects the cosmos' dynamics. One of the most challenging problems in astronomy is comprehending dark matter and how it affects the universe. Ongoing leap forwards by the James Webb Telescope have persuaded different examinations around the world. We now know more about the past and future of the galaxy as scientists investigate the mysteries of Andromeda and uncover more data. So, what have various studies revealed about the Andromeda Galaxy? Andromeda stands out from other galaxies scattered throughout the universe thanks to its impressive characteristics. Recent research suggests that it has a diameter of around 220,000 light-years, which draws attention to its sheer size. This figure makes it quite possibly of the biggest world in the neighborhood gathering, much greater than the Smooth Way. Its estimated trillion stars, which surpass our galaxy in number, add to its mass on account of its vast scale. The structure of the galaxy is also fascinating to researchers. Andromeda, in contrast to a typical spiral galaxy, has a bulging center and a dense nucleus enclosed within gas and dust rings. This demonstrates a dynamic galaxy created by ongoing processes shaping its evolution and is unquestionably a fertile ground for ongoing star formation. The double-peaked emission in its nucleus, which suggests the existence of a supermassive black hole similar to but distinct from the Milky Way's, is one of its many interesting characteristics. Astronomers can learn a lot about these massive black holes' behavior and nature from this. A sphere of stellar debris with stars, planetary systems, and globular clusters that span hundreds of thousands of light-years in diameter also surrounds Andromeda. The captivating and in-depth story of the galaxy's singular origin and history is told in this cosmic covering. The formation of star clusters and the early development of the galaxy are clearly explained by the 460 globular clusters found in Andromeda. These clusters provide insight into the early stages of star formation. Astronomers are one step closer to comprehending the significance of dark matter to the universe as they piece together the mysteries of Andromeda. However, a question remains: how do they explain its mysterious nature and its role in galaxies' dynamics? Andromeda's satellite galaxies are yet another distinctive feature. More than 20 smaller galaxies make up its halo structure, some of which are being stripped of their stars and gas by tidal forces. This process shows how galaxies grow and interact with one another over time by a larger galaxy pulling in and destroying smaller ones. It also shows how active cosmic evolution is. All in all, what does the future hold for the Andromeda world? Astronomers, as well as those interested in comprehending the universe, are captivated by its form and motion. The possibility of Andromeda changing from a spiral galaxy to a ring galaxy is crucial to its development. There is evidence for a process that could result in other uncommon combinations, possibly as a result of close interactions with other galaxies or galactic collisions. Since its inception, Andromeda has been involved in numerous interactions with other galaxies, which indicates that it is indeed moving in this direction. In the end, Andromeda's future is determined by its approaching collision with the Milky Way. These models predict that the collision will take place roughly 4 billion years from now. The consequence of such an impact is the introduction of another world from these two monster divine substances. The collision is a normal part of the development of the galaxy, despite its devastation. However, this galactic collision does not have a direct impact because of the vast distances between the galaxies. Both galaxies would undergo radical reorganization following the collision, resulting in new configurations and forms. As the merging objects twinkle brightly in the sky, new rounds of star formation will be sparked by the interaction of their gases and dust. One elliptical galaxy will emerge as a result of this cosmic event. The universe has a long history of collisions of this kind, so this one is not the only one. In any case, our immediate cooperation makes it an occasion important to us. In addition, the predicted collision of the two galaxies' supermassive black holes at their nuclei adds to the mystery of this celestial show and suggests that cosmic evolution is complex and deep. It is anticipated that the black hole-engulfed matter will explode during the merger, releasing a significant amount of radiation. This process provides important information about how galaxies evolve over time and how black holes affect this. Nonetheless, it brings up a significant issue. What will befall our planetary group after this consolidation is shaped? The solar system's orientation and conditions could be significantly altered, but not completely destroyed. This suggests possible ejection from the newly merged galaxy or even orbital shifts. Scientists can contextualize the eventual fate of our own galaxy and study the magnitude of similar events to comprehend this mechanism. It is vital to comprehend that an impact between stars is an uncommon occasion in space due to the huge intergalactic distances. However, the star's stable orbits could be disrupted by the gravitational shift, causing some stars, like the Sun, to change course. Such a change could definitely upset the environment on the planet. Moving either farther away from the Sun or closer to it is one of the most significant changes that humans could undergo. This could cause effects of either warming or cooling. Sea levels could rise and ice caps could melt in a warmer climate, while a colder one would bring about a new ice age. What's more, the calculation of such an arrangement could disrupt radiation levels coming to Earth, making significantly additional difficult circumstances. The merger of the Milky Way and Andromeda systems, in essence, exemplifies the intricate relationship between celestial bodies. As the dark openings in the two worlds draw nearer over the long haul, their gravitational activities might build the progression of high-energy particles that can arrive at Earth, at last making upgraded grandiose radiation enter our environment. Because it may result in an increase in genetic mutations and possibly affect the stability of Earth's climate, the potential increase in radiation levels may pose a threat to ecosystems on our planet. The variable activity that was detected by the James Webb Telescope points to an unexpected cosmic phenomenon that astronomers are rushing to better comprehend. From the development of new star frameworks to the appearance of unusual high-energy processes, these occasions are viewed as exceptional, further testing our perception of how worlds' capability and advance. The Andromeda Galaxy's future and its relationship to the Milky Way remain uncertain in light of these developments. The main thing we know is that there are more privileged insights left for us to reveal in the baffling universe.